Now, these are the hardest type of solving equations. We're not going to waste our time using the easy ones because you should have mastered that, let's be honest, when you're in year 7. So these are an equation because there's an equals and we're still asked to find a value, but this is using your knowledge of indices from day 1. So you can see here that 5 to the power of k plus 3 is equal to 5 to the power of a third, and because they have the same base value, we can say the powers are equal to each other because we're told that they are. So we can write this complicated thing as simple as this. So k plus 3 is equal to a third. So to find k on its own, it would be a third take away 3. So some of you might find that quite hard. You can obviously make this a fraction as 3 over 1, but it's not too bad. Maybe even if you think of it like this, minus 3 plus a third. So it's going to be minus 2 and 2 thirds. If you add a third onto that, let me just think. Yeah, that's right. Whoa, I took a long time doing that one. So that's minus 2 and 2 thirds. Alright, let's do the next one. So here we haven't got the base values the same. So we can't do something as simple as what we did then. So we're going to have to try and think of it, look at these and look for a number which we can write as the same base value, which is 4. Because 4 squared is 16, so that's the same, and that is 4 cubed, 4 times 4 times 4. Now using the power to power rule, I can say 4 to 2k is that, and now I've created the same scenario as before. So 2k is 3, and therefore k is 3 over 2, or 1.5. Now, same here, but this one's a little bit easier because we're told that 2, and that's the lowest any base value can really go. So what is this to the power of 2? So anything like this, you've got to be thinking indices. So 2 times 2 is 4. 8, 16, 32, so I know that is 2 to the power of 6, and therefore 3k take away 1 is 6, 3k must be therefore 7, and k is 7 over 3. Now this next question for solving equations is way harder, and they're really mean if they give you something like this, but I thought I'd better prepare you for it. So they're telling you, here's a rectangle, the area is 81, find the value of k. So we know that 3k plus 2 multiplied by the square root of 3 is 81. Now this is a surd, and you can get all wrapped up with surds and try and simplify this, but don't, because this is an indice, and when there's an indice, try and write everything as indices. So I'm just going to go ahead and write this, but I can write this in a different form using indices, and you should know that the square root is the same as to the power of a half. And now you can see I have the same base values. But this I also want in the same base value. And 81 is 9 times 9, but 3 squared is 9. So I know that 3 squared is 9, and then that squared is 81, so that must be 3 to the power of 4. 3 times 3 is 9, times 3 again, 27, times 3 again is 81. So now, we're multiplying the same base value, so we can add these. So we've got 3, we haven't got any other k's, but 2 plus a half is 2.5. So now we've got the same base value, so k plus 2.5 is equal to 4. So k is therefore 1.5, or 3 over 2. So that question is pretty mean, but there you have it. That is the hardest solving equations can actually get.